So here is a really fun research paper. It just got published in Radiation Physics and Chemistry. It was originally part of a master's thesis of one student, and the student that he worked with, and eventually this entire paper became a chapter in his dissertation. And what this shows is how to take conformal coat material that looks like this. This is after some destructive testing. It's just a polymer, a little polymer, but if you put a high Z metal oxide in it, like erbium or something like that, it'll look like these. These are what we did destructive testing with, these little dog bone samples. And all that it did is just give it a color. It's got a higher density because it's got a higher Z, more protons in the nucleus there. But the point is that what this paper shows, here's the reference, what this paper shows is that we can calculate for a given orbit how much material you need to extend the lifetime of the electronics. In other words, the electronics normally will have a very thin coat of this polymer right there. It's just a regular NASA compliant polymer that gives it a hermetic seal. But when I add a high Z metal oxide to it, it changes the color, but it turns it into a shield. It's got a lot of heavy metals in there that are in a rust form that allow it to attenuate electrons. And more specifically, like for example, a geostationary orbit, what this paper shows is that this shielding works like a magic bullet. It's amazing for the electron shielding. It's better than aluminum when it comes to the protons, so if you're in a low Earth orbit or something like that. But it works amazing for those electrons or X-rays or things of that intermediate energy. And so it's great work. Again, the reference right there. And really cool research. How do I take commercial off-the-shelf electronics and turn it into rad-hard electronics for space applications? So how do I shield electronics for radiation dose? It's pretty cool. And it just requires using these kinds of materials, our dog bones that we did where we did destructive tests. But it's really cool. So I hope you learned something, enjoyed the video, and you all have a great day.